Hey guys, what's up? It's Mr. Hutch here, and today we're starting a new unit all about different formulas, area, circumference, volume. So this is our formulas unit, module 12. This is lesson 12-1 on circumference of circles. Something you haven't learned in 6th grade, so this is new to you. Let's start off by talking about a couple vocabulary things. So you have these 3 vocabulary words. You may be slightly familiar with these words. Let's start off with the easy center right here. This from here to here is called the radius. And a radius just means from the center to any outside point, as long as it's a straight line segment. And then the diameter is double the radius, okay? Or you could say 2r, okay? 2 r's is the same thing or equals the diameter, okay? And so we can say diameter, okay? And so a diameter is the entire length through the center, though, okay? When you don't run through the center, that is called something else. All right, now, because the radius of the circle is the distance from the center to any point, the length of the diameter is always twice the radius. So you can see diameter equals 2 times r, or radius, you can say, is half of the diameter. Okay, so both those are accurate. Okay. Let's go ahead down here and explore a little bit about the circumference of circles. So the first thing you have to understand is this Greek letter, okay, which means pi, okay? And the value of pi is 3.1415926, and it goes on forever and ever and ever, okay? And so I want you to understand what pi is and where that comes from, okay? Here's a little model for you, okay? Essentially what it is whatever diameter you have, okay? This length of diameter, we're wondering how many times does this length fit in the perimeter of the circle? And so what you would find out is it would fit about 1, about 2, about 3, and a little bit, okay? And every time it's going to end up being 3.14 and so on, okay? No matter what circle you have, whatever its diameter is, it will fit 3.14 times around the circle, okay? So let me bring up this, and you can check it out.
It's about fitting the diameter as many times as possible into the perimeter of the circumference. Let's look here. 1, 2, 3, and a little bit more. That's it. We can fit 3 diameters into the circumference, and a small part, 0.14. That's why we know that pi equals 3.14. We say that it's a constant because number pi is the same for every circumference in the world. In other words, this number is always equal to 3.14. Would you like to check that? It's very simple. Look for a measuring tape and measure the perimeter of a round object you have at home. For example, the wheel of this bike. Divide the length of the perimeter by its diameter, and the result you'll get will be 3.14. Let's see. The perimeter of this wheel is 98.8 inches, and its diameter is 31.4 inches. If we divide 98.8 by 31.4, we'll get 3.14. Now measure the perimeter of this swimming pool. Divide the length by its diameter, and you'll also get 3.14. Let's see. The perimeter of this circular swimming pool is 51.5 feet, and its diameter is 16.4 feet. If we divide 51.5 by 16.4, we'll get 3.14.
All right, so notice that they used the term perimeter. Perimeter and circumference are the same thing. We just use that word circumference when we're talking about circles, okay? And so the formula for circumference is circumference, that's what the C is, equals 2 pi r, okay? Or we could do just, instead of 2 of the radius, we could just say d instead. Because remember, 2 of the radius is the same thing as d, okay? So that's why you see it written both those ways, okay? Now, you don't have to remember that, because right here is your formula chart, okay? And so you're going to want to have that handy, and you can see right here they have the circumference of a circle is 2 pi r, which is what you'll be able to use. You can remember, though, pi d is the same thing. Okay? So when you get your formula sheet for the PSSA, right away, if you want to write C equals pi times d, you could do that as well. Okay? Both of those are going to be valid ways of finding the circumference or the perimeter of a circle. Okay? So let's go ahead and use that formula, and we'll walk through how to solve circumference. Okay? So first section is finding the circumference if you know the diameter. Okay? So remember, the diameter is just twice the radius. Okay? They're letting you know the diameter is 23 feet from this location to this location. They also say it up here. Okay? One thing that you need to be aware of is you're always going to use 3.14 for pi. If your calculator does have a pi button, don't use that. Just use 3.14. Okay? Especially at this level of the math that you're in your journey. Okay? So all the time you are going to write the formula first. Okay? So circumference equals 2 pi r. Okay? Now, you can use this formula and plug in r, but realize the radius is half of that diameter. Okay? So 23 divided by 2 is 11.5. So underneath, you're going to substitute and say 2 times 3.14 times the radius, which is 11.5. You also, though, remember we know that circumference is pi times diameter. So we could say circumference is 3.14 times the 23. Okay, both of these are the same. Okay, let's go ahead and calculate them out. Okay, order of operations says we're going to do from left to right, but we know because of commutative it doesn't really matter. Let's go ahead and do 2 times 3.14 equals, and then times 11.5, and that tells us our circumference equals 72, and it says round to the nearest hundredth, so 2. Okay, and this is a distance around is circumference. Remember, it's like a perimeter, so it's just feet. Okay, we're not finding the area or anything like that. Now let's check and make sure this one matches too. So if we just do 3.14 times 23, you can see we get the exact same thing, 72.22. Okay, so it's up to you what formula you want to use. I'm just going to be showing you both as we go. So the distance around the clock is about 72.22 and 22 hundredths feet around. All right, the Niagara Sky Wheel, which overlooks Niagara Falls, Canada. That would be cool to go on. Maybe that would freak you out, I don't know. They're letting you know the diameter. So in my head right away, I would want to use the formula circumference equals pi times diameter. Remember, you could also use 2 pi r, okay? Because we have 2 of the radiuses, okay, or radii. All right, round to the nearest hundredth if necessary again. Since I know diameter, I'm going to choose to use this one. And we're going to do 3.14 times the diameter of 50.5. Let's go ahead and do that calculation. And we get the circumference around is 158 and 57 hundredths, and then look at your unit, that is in meters. Okay, and there we go. Okay, all right, let's go ahead and take a look at this. Now this is finding the circumference if we're given the radius. Okay, so last time we were given the diameter, and so you can sort of think which formula is going to make more sense. There's a radius of 21.2 inches. So we know that the formula, and if I didn't remember, I could look at my formula sheet, for circumference is 2 pi r, or circumference equals pi d. Okay? For this one, I'm going to use 2 pi r, since I know the radius. I could do diameter. I would just have to double the radius, right? Okay. So let's go ahead and plug this in. Okay. We have 2, 3.14, and the radius is 21.2. Okay. Again, if I wanted to do times pi d, I could do circumference equals 3.14 times the diameter, which would just be double the radius. So let's see, what, 42.4. Okay. So that's another option if you prefer to just always do pi times d instead. You just have to be careful when you're doubling or halving diameters or the radius, okay, that you don't make a mistake. All right, let's go ahead and solve this out. So 2 times 3.14 equals times 21.2, and we get the circumference of this circle is 133.14. It says round to the nearest hundredth. Let's check our other one, 3.14 times 42.4, and you can see we get the exact same thing. Okay, so both options are valid methods. You choose and stick with what you prefer. But there we go with our circumference. All right, let's go ahead and check. Have you try this out? The radius is 9/10 of a centimeter. What is the circumference? Okay, so go ahead and pause and you can try it out on your own. All right, here's what we got. I'm going to use circumference equals 2 pi r, since I know the radius. Circumference equals 3.14 times 0.9. Plug it into my calculator, times 3.14 times 0.9, and we get circumference is 5.65 rounded. And let's look if there's any units. There is centimeters, and there we go. Okay. All right, down here, we have some different dimensions that we are missing now. Okay, so maybe we don't know the diameter, or maybe we don't know the radius. You're going to plug in what you know and solve for the variable. Okay, so let's go ahead and check these out. Okay, for these, for example, 3, find the diameter if we're given the circumference this time. Okay, so given the circumference, we're just going to still use the same formula, plug in what we know, and solve for the variable. In the other ones, the variable was already on one side, so it was easy. We just solved to the one side, and the variable was already isolated. This time, our variable will not be isolated. We're going to have to do that. One of the largest water fountains in the world, Singapore's Fountain of Wealth, consists of a circular bronze ring, and they're giving us the circumference of 66 meters. Okay, they want us to find the diameter. So think about what formula you're going to use. Okay, I'm going to use circumference equals pi d. So always, the first rule is always write the formula, then substitute. Okay, I know the circumference is 66 meters. Pi is going to be 3.14. I'm going to put that in parentheses, or I can put d in parentheses. The diameter is d. Okay, and since it's not a number, technically, I don't even need parentheses. I could just put a d here. Okay, so how do we isolate d? Well, I have 3.14 times d. How do you get rid of that or undo it? Divided by 3.14 to both sides, just like we normally do. This is going to create one whole, which will leave us with 66 divided by 3.14, and we get, round to the nearest hundredth, 21.02. And that is, let's look at our units, that's meters, equals the diameter. Okay, And so there we go. We're all set. If you wanted to check, which I know some of us are lazy, so we probably wouldn't do that, but 21.02 times 3.14 should get us pretty close to our 66, which it does. Okay, and remember, we rounded, so it makes sense that we have that 0.0028. Okay. All right, so there you go. There's your diameter, and that's just how you would work back and isolate the variable. Go ahead and try it out with this one. They're letting you know that the diameter of a basketball hoop approximately is what you're trying to find. We know the circumference is this many inches. So set up your formula, plug in and substitute what you know, and then go ahead and isolate your variable. Okay, go ahead and pause. All right, let's see how you did. So we know the formula for circumference, and then decide, are you going to do pi d or 2 pi r? Okay, so I know I'm trying to find the diameter, so I'm going to do pi times d instead. Okay, circumference is 56.52 equals 3.14 d. And then let's go ahead and solve for d. How do I get rid of a times 3.14? Well, we would divide it on both sides, and we're going to get d equals, and this is going to be in inches. Let's see what we get. 56.52 divided by 3.14. If you got this, then you are correct. So the diameter of a basketball hoop is 18 inches. Okay, so pretty cool. All right, what if we're given the circumference and you want to find the radius? Okay, so now think about what formula you're going to use. Do I want to use circumference equals 2 pi r or pi d? Well, since I'm dealing with radius and wanting to find radius, I'm going to use circumference equals 2 pi r. Okay, plug in what we know. Circumference is 70.82 inches. I don't need the inches to do the math work. Equals 2 times 3.14. Since I have two numbers next to each other, I need to put the 3.14 in parentheses. And then the radius, I don't know, so I'm just going to put an r. Okay, let's go ahead and combine like terms. So one thing you should see is you have this math problem here we can take care of. So we have a 2 and a 3.14. We're not really combining like terms because it's not addition and subtraction, so poor word choice. But essentially, let's solve what we can solve before we start moving things around. Okay, so we have 2 times 3.14, and we get 6.28. Oops, let's not write with highlighter. Let me change colors too. 6.28 times r equals 70.82. Isolate the variable. Let's go ahead and divide by 6.28, both sides. And then this is going to create one whole, and we're left with the radius is a certain amount of inches. Let's see what that is. 70.82 divided by 6.28, and we get a radius of about 11.2, round to the hundredth, yep, 0.28 inches, okay, is the radius, okay? Just for the purpose of double checking, 11.28 times 3.14 equals times 2 equals my 70.83, about 82, perfect, good. All right, and so there we go. Circle my answer. That's what my radius is. Okay. All right, go ahead and try this one on your own. It says find the radius. Okay. So we have a circumference of 7.92 centimeters. Go ahead and pause and try it out. All right, because I'm trying to find radius, I'm not going to use pi d. I'll use 2 pi r. Okay. And plug in what I know. Circumference of 7.92 equals 2 times 3.14. And r, let's go ahead and solve what we can first. So 2 times 3.14 is our 6.28. Okay. And we have our R equals 7.92. Divide both sides by the 6.28. And we're left with R equals, and this is centimeters. Let's see, 7.92 divided by 6.28. If you got this, you are correct. 1.26 centimeters is the radius. Okay. All right. Now you can see we're kicking up to a little higher level here. So they're letting you know that a circular garden exists with a radius of 3 feet. Okay. This neighbor has a circular garden that is 2.5 feet longer than the diameter of this other person's garden. So you can see they drew a picture to just show that it's 2.5 feet longer, okay, of a diameter, that is. And so how much landscape edging does the neighbor need to border her garden? Okay, so what you need to understand is the center of this large circle is not right here, okay? The center of it would be somewhere here, right? And so we need to figure out what is the distance from this location all the way across to this location so that we can do circumference equals pi times d, okay? So look at the information you have. We know that this distance is 3, and so we know that this radius is also 3, okay? And now you can sort of visually see that we have 3 plus 3 is 6, plus the 2.5 is 8.5 total, okay? And so our diameter going all the way across, if we include this other 3 feet, is a total diameter of 8.5 from this point all the way to this point, okay? And that's our diameter, okay? So let's go ahead and solve this out. We have circumference equals, I'm going to use pi d, okay? I could use 2 pi r, but I have to take 8.5 and divide it by 2, and I don't really feel like doing that. Let's just go ahead and plug this in. This is less math work anyway. So circumference equals 3.14 times, we'll put it in parentheses, 8.5, and it'll give us our answer. And there we go. Our circumference around is 26.69, and we're rounding the nearest hundredth, so we're good. Let's put our units. Don't ever forget that, and that is feet. Okay, so there we go. All right, let's move down to this one. This one's for you to try out. A nickel has a diameter that is 2.16 millimeters longer than the diameter of a penny. Okay. If the radius of a penny is 9.525 millimeters, what's the circumference of the nickel? Be careful. They're letting you know the diameter is this many millimeters longer than the diameter of a penny. And then they're giving you the radius of a penny. Okay? So it may help for you to draw a picture. So go ahead and pause, try it out, see what you can get, and then you can follow along with me to check your work. All right, so I'm going to do a little drawing here. This is going to be my penny. I know the radius of this penny is 9.525, okay, and that's millimeters, okay, and then a nickel, I'm going to just draw a bigger circle, okay, it doesn't have to be to scale or anything, it's just for drawing purposes. It says is 2.16 millimeters longer in diameter, okay, so I can see the diameter of my penny, it's that whole distance, and this distance is 2.16 millimeters more, okay, so what is my whole thing? Well, my whole thing is the 9.525 plus 2.16 plus another, right here, 9.525 millimeters. So we need to add that up to get our diameter for our nickel. Okay, so I don't want to risk making a mistake here, so let's go ahead and add it up. 25 plus 9.525 plus 2.16, and my entire diameter is 21.21. Okay, so from this point, wow, as I erase everything, so from here all the way to here, we have 21.21 millimeters, and that's my diameter. Okay, now that I know that, we can solve the circumference for our nickel. So circumference equals pi d. Circumference equals 3.14 times my 21.21. And then let's go ahead and plug it in. 21.21 times 3.14 pi gets us 66.59, rounded 66.60. But I don't put extra zeros on at the end, so we're going to stop it at 66.6. Ooh, it says round to the nearest tenth. Let's look at that. 66.59 would round to 66.6, so we're good with that as it is. Make sure we get our units in there. You don't want to lose a point for getting that, and there we go. That's the circumference of a nickel. Try it out. Find out if it's true. All right, your homework is this. It's just the one page. It wants you to find the circumference of the watch face, a circular fence, all that. You can see if you need help. It lets you know which example you can look at to get help for these. Example 3, example 3, example 4, and then your final one, number 8, tells you find the approximate radius when given a circumference. Okay, so go ahead and try that homework out and see how you do.